This is part 2 of the review for sections 6.1, 5.1, 6.2, and 5.2. Number 17. A 20-foot ladder leans against a building so that the angle between the ground and the ladder is 72 degrees. How high does the ladder reach on the building? I'm going to draw a picture. So here's my building. And then here's the ladder. The ladder is 20 feet long, so 20 feet goes right here. The ground, we normally say, makes a right angle with the building. The angle between the ground and the ladder is 72 degrees. We want to find out how high up the building the ladder goes. So in order to find h, I need to ask myself which trig function I'm going to need to use to solve for h. Since I want to find the side opposite, and I know the hypotenuse, I'm going to use the sine. So the sine of 72 degrees is equal to h over 20. Now, double check what mode your calculator is in, because for this problem, the angle is in degrees, so we need to be in degree mode. So h is going to be 20 times the sine of 72, which is approximately 19 feet. Number 18. A water tower is located 325 feet from a building. From a window in the building, an observer notes that the angle of elevation to the top of the tower is 39 degrees, and that the angle of depression to the bottom of the tower is 25 degrees. How tall is the tower? How high is the window? So there are two things I want to find, and I'm actually going to start with the easy one, which is how tall up the building is the window, because this is a right triangle, and I know the bottom of the triangle is 325 feet. And because I know that this angle here is 25 degrees, by alternate interior angles, I also know that angle is 25 degrees. So I want to find how high up the building we need to go, x. So the trig function I'm going to need to use to find out how high the window is, oops, I didn't mean to cross it off, I meant to underline it, is tangent. The tangent of 25 degrees is going to equal the side opposite x over the side adjacent, 325. So x is 325 times the tangent of 25 degrees, and I'm going to find out that x is approximately 151.5 feet up the building. It's finding the height of the water tower that's going to take a little bit more work. Here's going to be the height of the water tower, and I'll call this portion up here, we'll call it height 1, and then this portion down here, we'll call it height 2. If I can set up two trig functions for this and find height 1 and height 2, then I'll be able to add them together to find the total height of the water tower. Well, because I know this portion down here is 325 feet, I also know this part is 325 feet because it makes a rectangle. So let's start with this triangle up here. I am going to use tangent again to set up a trig function for finding height 1 because I have this angle. Height 1 is the side opposite, and 325 is the side adjacent. So the tangent of 39 degrees is going to equal height 1 over 325. So height 1 is going to be 325 times the tangent of 39 degrees, which is approximately 263.2 feet. To find height 2, I'm going to use tangent again because here's 25 degrees. I want to find the side opposite, and I know the side adjacent. So the tangent of 25 degrees is going to equal height 2 over 325. So height 2 is going to be 325 times the tangent of 25 degrees, which is approximately 151.5 feet. To find the total height, I'm going to add these two numbers together. So the total height of the water tower is going to be 414.7 feet. Number 19. To estimate the height of a mountain above a level plain, the angle of elevation to the top of the mountain is measured to be 32 degrees. 1,000 feet closer to the mountain along the same plane, it is found that the angle of elevation is 35 degrees. Estimate the height of the mountain. Well, let's draw a picture. Here's a mountain, and here's my level plane. From this point here to the top of the mountain, we're going to say is 32 degrees. But if I move 1,000 feet closer, which we'll say is here, so this is 1,000 feet. Oops, I should make that actually say 1,000. The angle of elevation to the top of the mountain is instead 35 degrees. We want to find how high the mountain is. So there are two triangles here, and one of the things I don't know is I don't know how far it is from the mountain to this first point. We'll call it x. So from the mountain to the end of this point here, where I took another angle of elevation, must be x plus 1,000. So we're going to set up two trig functions in order to find the height of the mountain. So let me start with this triangle here. To find the height of the mountain, we're going to use tangent because opposite 35 degrees is the height and adjacent is x. So the tangent of 35 degrees is equal to h over x. Now I'm going to look at this triangle, which I'm also going to use tangent for. This time it's the tangent of 32 degrees is equal to the height of the mountain over the bottom of the triangle is x plus 1,000. Since the height of the mountain has to be the same for both triangles, we're going to solve both of these equations for h, and then set the two equations equal to each other to find out what x is. So in the first equation, h is going to equal x times the tangent of 35 degrees. And in the second equation, h is going to equal x plus 1,000 times the tangent of 32. Now, in order to do this problem, we're actually going to change things into decimals. So the tangent of 35 is 0.7002. So I have 0.7002x. And that's going to equal x plus 1,000 times the tangent of 32. The tangent of 32 degrees is 0.6249, and then I'm going to distribute. So I get 0.6249x plus 0.6249 times 1,000 is 624.9. I'm going to get my x's on the same side by subtracting the 0.6249x. And I'm going to get 0.0753x is equal to 624.9. And then I'm going to divide by 0.0753. And I'm going to find out that x is approximately 8299 feet. Well, now that I know what x is, now I can find h. And the easiest way to do it is to use this equation. The tangent of 35 degrees is equal to h over 8299. So 8299 times the tangent of 35 is approximately 5,811 feet. So I wrote two equations for two different right triangles, both that had the height of the mountain in them. I solved both equations for h and set the two equations equal to each other and solved for x. In order to do that, I took the tangents and converted them into decimal equivalents. And then I just did simple algebra to finish finding x. Once I found out that x was 8,299, I plugged it back into one of the two equations, the one I thought was the simpler one, to find out what h was. Number 20, find the exact value of each trigonometric function given. Now, in order to figure out what the sine of 2 pi over 3 is, there's a couple things I need to know. One of the things is, what quadrant is 2 pi over 3 in? Now, if you forget what quadrant it's in, you can always change it back into a degree measure. So 2 times 180 is 360, and 360 divided by 3 is 120 degrees. And 120 degrees is in quadrant 2. In quadrant 2, are sines positive or negative? Well, if you remember all students take calculus, you'll know that in quadrant 2, sines are positive. Well, then I need to know its reference angle. The reference angle is the easy part. It's pi over 3, which means that its terminal point is 1/2, square root of 3 over 2. Remember that in these ordered pairs, the first value is the cosine of the angle, and the second value is the sine of the angle. So the sine of our angle 2 pi over 3 must be square root of 3 over 2. Positive because it's in quadrant 2. In B, what's the cosine of 2 pi over 3 going to be? Well, in quadrant 2, we know that only sines are positive, which means cosine must be negative. And the cosine, if you look at the previous ordered pair, has to be 1/2. So the answer should be negative 1/2. C, I want to find the tangent of 2 pi over 3. Tangent, we said, was sine over cosine. So sine over, remember we're in the second quadrant, so the cosine is negative. And the nice thing about these is the 2's just go away, so you get negative square root of 3. Now let's do some different ones. How about the cosecant of negative pi over 4? Well, a couple things. Number one, I know that the reference angle is pi over 4, which is 45 degrees. I know negative pi over 4 is going to be in quadrant 4. And I know that in quadrant 4, only cosine and its reciprocal are positive. Cosecant is the reciprocal of sine. So I know the answer is going to be negative something. Well, if the reference angle is 45 degrees, then the ordered pair is 1 over radical 2, 1 over radical 2. Or you could tell me it's square root of 2 over 2, square root of 2 over 2. Remember, both of those ordered pairs are the same. The cosecant is the reciprocal of sine. So here's my sine, here's its reciprocal. Or you can tell me it's negative square root of 2. That's fine too. For cotangent of negative pi over 4, since cotangent is a reciprocal of tangent, in quadrant 4, this answer will also be negative. Cotangent is going to be cosine over sine. So cosine over sine, you're going to find out is 1. And since it's in the fourth quadrant, it's going to be negative 1. And the last one, the secant of negative pi over 4. Well, the nice thing is secant is the reciprocal of cosine. So we know the answer is going to be positive. So what's cosine? Cosine is square root of 2 over 2, or 1 over the square root of 2. What's its reciprocal? Square root of 2 over 1. Number 21. If the terminal point of an angle is at the following ordered pair, find its sine, cosine, and tangent. Well, if this is the terminal point, then I know that this is the cosine of theta and this is the sine of theta. The only other thing I need to find is what's the tangent of theta. Well, remember I just said tangent is sine over cosine. So sine over cosine. And these go away and you're left with negative 21 over 20 as its tangent. Number 22. Find all the trigonometric ratios of an angle if secant theta is equal to 3 and the angle lies in quadrant 4. Well, this is what I'm going to do. I'm going to start by drawing a picture. Here's the coordinate plane, and here's my terminal ray in quadrant 4. To draw my triangle, I'm going to drop a perpendicular to the x-axis. And theta is always the angle between the terminal ray and the x-axis. If the secant is 3, remember that's the same as 3 over 1. If I know secant, then I also know its reciprocal, which is cosine. And if I know the cosine, then I know the side adjacent, and I know the hypotenuse. And I can use the Pythagorean theorem to find the side opposite. So the side opposite, I use y because in the formulas we use that use x, y, and r, x was the value of the triangle along the x-axis, y was the value of the triangle parallel to the y-axis, and r was the radius. So 1 plus y squared is equal to 9, so y squared is equal to 8, so y is equal to the square root of 8, which is also the 2 square root of 2. I don't care which one you use. Since this is in quadrant 4, y is negative. So now the sine of theta is negative square root of 8 over 3. Its reciprocal cosecant must be negative 3 over the square root of 8. And the tangent of theta must be negative square root of 8 over 1. So the cotangent must be negative 1 over the square root of 8. And again, I don't care if you simplify the radicals, and I don't care if you rationalize the denominators. You can leave the answers just like this. Problem 23. The displacement from equilibrium of an oscillating mass attached to a spring is given by the following formula, where y is measured in inches and t is in seconds. Find the displacement at the times indicated in the table. Now the equation that describes the motion of this oscillating mass is y of t equals 4 times the cosine of 3 pi t. Now what's happening is a spring in equilibrium is a spring with a mass on it just hanging, and you don't put it in motion. It's not flopping up and down. Well, if you were to pull on the spring is going to do a motion called oscillation. It's going to go up and down and up and down. And when it's doing that, this equation represents the motion of that oscillation. We want to find out where the mass on the spring is at different times t. If equilibrium is when, I shouldn't say that, it's when, y equals 0. When I use d for displacement instead of y of t. Sorry about that, I'm used to d for displacement. Basically, y of t represents its location in respect to equilibrium, and equilibrium is when y equals 0. So all you have to do is plug these numbers into that equation for t. And it's really simple, it's just a plug and chug problem, but there is one thing you have to determine. What mode should your calculator be in? So I want you to notice. See that pi? We're going to be in radian mode. A lot of times when we use trig equations to represent motion, we're going to do it with our calculator in radian mode. So, plug in 0 for t. 4 times the cosine of 3 pi times 0 gives you 4. Doesn't look like a nice 4, there we go. Plug in 0.25 for t. 4 times the cosine of 3 times pi times 0.25 is negative 2.83. 4 times the cosine of 3 pi times 0.50 is 0. That means it's back at equilibrium. Time 0 is if I were to pull the mass and stretch it below equilibrium. So we're at 4. And then at 0.25 we're above that equilibrium line. At 0.50 we're at the equilibrium line. At 0.75 seconds, I guess is what this is measured in, 4 times the cosine of 3 pi times 0.75 is 2.83. At 1 second, 4 times the cosine of 3 pi times 1 is negative 4. And then 4 times the cosine of 3 pi times 1.25 is 2.83 again. And that concludes the review for this quiz. Just a reminder, this may have seemed like a lot of problems, but remember there are 2 parts to the quiz. One part is a multiple choice, and the multiple choice will comprise some of our simpler problems, primarily ones that we also focused in on in Algebra 2. The second part, the free response portion of the test, will include a lot more application problems or word problems that you'll need to solve.